Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this video, we are going to see about alloys. Alloys is an important part in today's engineering chemistry. So, alloys are generally the metals that are insoluble in ordinary solvents. For example, if you take it is not soluble in water, alcohol, etc. But a metal can be dissolved in another metal in the molten state, forming a homogeneous liquid mixture. So these mixtures it solidifies on cooling, and most of the metals can mix up in all proportion. And this solid is called as an alloy. So example, when we take a lead and tin, they mix up in all proportion forming alloys. Alloys are formed not only by metals among themselves, but also a metal and the non-metal can form an alloy. So you can define alloy as a homogeneous solid solution of two or more different elements, one of which at least is essentially a metal. So alloys containing mercury has a constituent element are called amalgams. So we have to note that in alloy at least one element is a metal. Then properties of alloys. Alloys are harder, less malleable and possess low melting point than their component metals. So you can see that alloys, what is the purpose of alloying? That is to improve the property of the metal. So alloys possess low electrical conductivity, alloys resist corrosion and the action of acids. Significance or purpose of alloying. Generally, pure metals possess some useful properties such as high melting point, high densities, malleability, ductility, good thermal and electrical conductivity. So, as we've seen, the properties of a given metal can be improved by alloying it with some other metal or non-metal. So, the purpose of making alloy is to increase the hardness of the metal. Generally, pure metals are soft but their alloys are hard. So, for example, if you take gold and silver or soft metals, they are alloyed with copper to make them hard. So, while they are designing any jewelry design, so copper is added to gold to make a perfect design. Then addition of 0.5 percentage arsenic makes lead so hard and used for making bullets. So that just the 0.5 percentage of arsenic is important in this case. Then addition of 0.15 to 2 percentage carbon to ion for getting the steel hardness is improved to it. So we know the hardness of the steel. Next is to lower the melting point of the metal. Alloying makes the metal easily fusible. So, for example, in Wood's metal, that is an alloy of lead, bismuth, tin, and cadmium, it melts at 16.5 degrees centigrade, which is far below the melting point of any of these constituent metals. Next point is to resist the corrosion of the metal. So metal in the pure form are quite reactive and easily corroded by the surroundings. So they are easily replaced. When it is used in the large machineries, they should be easily replaced so that there is wastage of the metal and the money. So but if a metal is alloyed, it resists corrosion and it is durable for a very long time. So example, pure iron gets rusted, but when it is alloyed with a carbon or chromium, that is the stainless steel, it resists corrosion. So in the most of the cases, instead of the pure iron, you use the stainless steel to prevent the corrosion. Next is to modify the chemical activity of the metal. So chemical activity of the metal can be increased or decreased by alloying. So sodium amalgam is less active than sodium, but aluminum amalgam is more active than aluminum. So the amalgam is nothing but it's an alloy that is got with the addition of mercury. So to modify the color of the metal, the dull colored metals are improved by alloying with metals. So this is for the decorative purposes. Example, brass, an alloy of copper, it is red, and zinc, it is silver white, is white in color. Next, the property is to get good casting of metal. So some metal expand on solidification but are soft and brittle. The addition of other metals produce alloys which are hard, fusible and expand on solidification and thus give good casting. So for the casting, the alloying is very important. So example for this, an alloy of the lead with 5% tin and 2% antimony is used for the casting printing type due to its good casting property.